In a world driven by rapid technological advancement and constant discovery, it is both astonishing and deeply inspiring that the ideas of one man, conceived over a century ago, continue to shape and redefine our understanding of reality. Albert Einstein, a name synonymous with genius, revolutionized physics with theories that challenged conventional thinking and expanded the boundaries of human knowledge. Today, in 2026, his brilliance once again takes center stage as modern science confirms, refines, and builds upon his groundbreaking insights. Einstein's genius has not only stood the test of time, it continues to actively transform how we see the universe, proving that true innovation is timeless. At the heart of Einstein's legacy lies his theory of general relativity, introduced in 1915. This theory fundamentally changed our understanding of gravity. Before Einstein, gravity was seen as a force acting at a distance, as described by Isaac Newton. But Einstein proposed something far more profound. Gravity is the result of massive objects bending the fabric of space-time itself. Imagine placing a heavy ball on a stretched rubber sheet, the sheet curves, and smaller objects roll toward the heavier one. This simple analogy captures the essence of Einstein's revolutionary idea. It was a bold departure from classical physics, and at the time, it seemed almost too abstract to be proven. For decades, many aspects of general relativity remained theoretical, supported by mathematical equations, but lacking direct observational evidence. However, as technology advanced, scientists began to find ways to test Einstein's predictions. One of the most remarkable confirmations came with the detection of gravitational waves, ripples, in spacetime caused by massive cosmic events. These waves were first directly observed in 2015, a century after Einstein predicted them. But in 2026, new observations have taken this confirmation to an entirely new level, demonstrating once again that Einstein's insights were not only correct, but astonishingly precise. Recent discoveries involving the collision of massive black holes have provided some of the clearest and most powerful evidence yet of gravitational waves. These collisions occur billions of light years away, in regions of the universe that are otherwise invisible to traditional telescopes. When two black holes spiral into each other and merge, they release an enormous amount of energy in the form of gravitational waves. These waves travel across the universe at the speed of light, stretching and compressing space-time as they pass. By the time they reach Earth, they are incredibly subtle, yet detectable thanks to highly sensitive instruments like the Laser Interferometer Gravitational Wave Observatory, known as LIGO. What makes the latest findings so extraordinary is the level of detail scientists can now extract from these signals. Using advanced computational methods and artificial intelligence, researchers are able to analyze the waves and reconstruct the events that produce them. They can determine the masses of the black holes, their Arabic, Sin Arabic, Rot Arabic, Tain Arabic Tet, Ma But, their rotation, and even the nature of their He Untum Ins merger. This level of precision allows scientists to test Einstein's equations under extreme conditions that push the limits of our understanding of physics. And once again, Einstein's theory holds true. But this is more than just a scientific validation. It is a powerful reminder of the importance of imagination and curiosity. Einstein did not rely on advanced machines or massive datasets. He relied on thought experiments, mental exercises that allowed him to explore complex ideas in a simple yet profound way. He imagined riding alongside a beam of light, visualizing how time and space would behave under such conditions. These thought experiments led to insights that would later be confirmed by some of the most sophisticated technology ever created. It is a testament to the power of the human mind and the limitless potential of creative thinking. The integration of artificial intelligence into modern scientific research marks another significant milestone in this journey. AI systems are now capable of processing vast amounts of data at incredible speeds, identifying patterns and signals that would be impossible for humans to detect alone. In the context of gravitational wave research, AI plays a crucial role in filtering out noise, enhancing signal detection, and accelerating analysis. This collaboration between human ingenuity and machine intelligence represents a new era of discovery, one in which the boundaries of knowledge are expanding faster than ever before. Einstein's genius also extends beyond physics. It serves as a source of inspiration for people across all fields. His story is not just about equations and theories, but about perseverance, curiosity, and the courage to think differently. He faced skepticism and criticism, yet remained committed to his vision. Today, his ideas are not only accepted, but celebrated as some of the most accurate descriptions of reality we have. This journey from doubt to validation is a powerful lesson for anyone pursuing innovation or creativity. As we reflect on the continued relevance of Einstein's work, we are reminded that the pursuit of knowledge is a never-ending journey. Each discovery opens new questions. Each answer reveals new mysteries. Gravitational waves, for example, have introduced a completely new way of observing the universe. Unlike traditional astronomy, which relies on light, gravitational wave astronomy allows us to listen to the cosmos. It provides insights into events that emit little or no light, such as black hole mergers. This new perspective is transforming our understanding of the universe and revealing phenomena that were once beyond our reach. Looking ahead, the implications of these discoveries are profound. Scientists are already exploring the possibility of detecting gravitational waves from the early universe, potentially offering clues about the origins of space and time itself. There is also ongoing research into whether deviations from Einstein's theory might exist under certain conditions, which could lead to new physics and a deeper understanding of reality. Yet, even as we push the boundaries of knowledge, Einstein's framework continues to serve as a reliable foundation. For viewers and learners, this story is an invitation to explore, to question, and to imagine. It shows that even the most complex ideas can be understood with the right perspective, and that curiosity is the driving force behind all progress. Whether you are a student, a creator, or simply someone fascinated by the universe, there is something to be gained from Einstein's legacy. His work encourages us to look beyond the obvious, to challenge assumptions, and to seek deeper understanding. In a time where information is abundant and attention is limited, taking a moment to appreciate the depth and beauty of scientific discovery can be incredibly rewarding. It connects us to something larger than ourselves, a universe filled with wonder, complexity, and endless possibility. Einstein's genius reminds us that we are capable of understanding this universe, not just through observation, but through imagination and insight. As we continue to explore the cosmos and unlock its secrets, one thing remains clear: the impact of Einstein's ideas is far from over. His genius continues to guide us, inspire us, and challenge us to think beyond the limits of our current understanding. In 2026 and beyond, his legacy lives on not just in textbooks and laboratories, but in every curious mind that dares to ask, "What if?" Welcome to Einstein AI, where science meets inspiration, and where the ideas of the past continue to shape the future. Rocket